And the camera has decided to focus elsewhere. Okay, and maybe it'll come up. Okay, focus. I think the camera's in focus. Okay, we had a little bit of trouble here. I think I better show you. The idea is simple enough, and you see why it works out if you do what you need to do. Got 4 minus the square root of 2 here. Turns out if we multiply that by 4 plus the square root of 2 and use the distributive law, the radicals are going to go away. Of course, we can't multiply this by 4 plus the square root of 2 unless we also multiply this by the square root of 2, at least if we don't want to change the actual value of the expression. Okay, so we're multiplying. Okay. I hope you didn't already do what I said to do, because I just wrote 2 plus the square root of 7. And that should be, yeah, that wasn't going to work. Okay, the numerator and the denominator were different. So I pretended to screw that up just to make the point. Okay, well, I'm off to a good start because I really did screw that up. Wrote it down carelessly. Hopefully he'll learn not to do that. Okay, should be 4 plus the square root of 2, right? Now, use the distributive law. Just multiply the numerators and multiply the denominators. Multiplication by fractions and rational expressions is real easy. Unlike addition, which gets a little complicated with common denominators and so forth. Okay, when I said use the distributive law, what I meant by that is you multiply the numerators and you multiply the denominators. You don't want to skip that step. You're going to write this out as 2 plus the square root of 7 times 4 plus the square root of 2 divided by 2 plus the square root of 7 times 4 minus the square root of 2. Okay. So that's the next step, but then you apply the distributive law, because each of these is an expression that can be evaluated or simplified using the distributive law. Okay. Just to illustrate numerators. This times this is 2 times this plus the square root of 7 times this, right? Which is 8 here now, and 2 square root of 2. Okay. And then 7 times square root of 7 times 4, which I'll write 4 square root of 7 plus the square root of 14. So these two terms here add up to 6. What they don't, because they have different. Okay. Square root of 2 4 square root of 7 square root of 14. If you're missing any of those terms, I will write out the distributive law in detail. Okay. Please get in the habit of writing out the distributive law in detail. Because it'll hang you up when you're in your pre-calculus class. If you don't know how to do that, don't remember how to do that. Okay, I was more careless than I thought I was when I wrote down this 2 plus the square root of 7. Actually, I wrote something down wrong here, and I wrote it down wrong here. I should have 2 plus the square root of 7 here, 4 minus the square root of 2 here. And when you simplify that, it works out really nicely. Now, most of you got at least most of what you should have here. Okay. So I think you're in pretty good shape there, but careful about that one little detail, okay? I'm sorry for being misleading on this, but and there should be 4 plus a square root of 2. Because that's what we had here, right? I wrote it down. There's a pattern in my head and I didn't bother to check it out. So I got it confused. Okay, well, there it is. We'll work this one out in a minute. We give everybody just a couple more minutes to ponder and make sure you got it right. Okay. There's a tendency to still have some problems with the distributive law. Okay. So I'm going to write that down here. Multiply A times B plus C. You get A times B plus A times C. Now there's another one you multiply on the other side. I'm not going to write that one down because it feels about the same, okay? So it follows that A plus B times C plus D equals A. Actually, the way I wrote this, try to be careful for change. If you write it in the order I wrote this, what am I multiplying by this? Instead of an A here, I've got an A plus B. So this means I've got A plus B times C plus A plus B multiplied by D. And that means then A plus B times C is A times C plus B times C. And then A plus B multiplied by D is A times D plus B times D. Okay, I'm going to use this space here. We'll work this one out elsewhere because I've already used up too much space to keep it on this board. Okay. Now we could also write this as A plus B times C equals AC plus BC. And then follows it. A plus B times C plus D would be equal to well, if A plus B times C is AC plus BC, then if instead of C, I've got a C plus D over here, and the A plus B over here, then it's instead of A times C, we're going to multiply A times C plus D. And then we're going to multiply B times C plus D. Okay? And that then is equal to AC plus AD plus BC plus BD, which is the same as what we got here, but it came out in a little different order when I chose to use this form of the law, okay? But it's the same thing, and we say that multiplication distributes over addition. In other words, you have this multiplication, it's going to multiply by each of the things that's added. And the result is going to be the sum of those two things. So it's a really important rule, as I've said several times. You don't want this hanging you up in your pre-calculus class. Okay, and it's also the basis of most of the factoring that we did over there. So you want to really be clear on this. And now we apply it here and see what we get. Okay, I just realized that I'd done a really boneheaded thing and hadn't recorded this. So here is another one to work on. You can ignore me unless you really want to see me explain all this again. Because we went into a lot of detail on this. Okay. Okay, so anyhow, y'all go ahead and work on that. I'll go through this a little faster, but I want to emphasize the same things I did before. Okay, if we have this expression, then what do? We multiply the denominator by the sort of opposite expression. Instead of 8 plus 13, we want to multiply by 8 minus the square root of 13, square root of 13. I didn't say that right. If we multiply the denominator by 8 minus the square root of 13, we change the value of the expression unless we also multiply the numerator by 8 minus the square root of 13. So this is a basic principle in changing the denominators of a fraction. Unlike when we're adding fractions, we're not trying to do a common denominator. We're trying to rationalize the denominator. And what we're going to end up with for the denominator, once we get through all the steps of the distributive law, is just a plain old number, in this case, 51. But we want to see how the rules apply and how we get there. And so when we multiply two rational expressions of two fractions, we multiply the numerators and we multiply the denominators. So the numerator here is 6 minus the square root of 10 times 8 minus the square root of 13, which we write here. We don't want to skip any of these steps at this point. We want to reinforce the distributive law and the other aspects of the algebra of this problem. If we do the algebra by the way it looks, we're going to mess up, okay? If we don't always check it with the basic rules. There are only about a dozen basic rules. You want to follow all those rules. Okay, so the denominators, of course, multiply. So we have this times this, which I write here with parentheses in standard form. And now I multiply this by this using the distributive law. Okay, 6 times this minus 10 times this. 6 times this minus 10 times this. Matches up. It looks right, and we can verify it by writing out the distributive law and making sure we understand. If we write all the steps of the distributive law every time we use it in this course, it's more likely to be there so you don't stumble over it in your pre-calculus course. Okay. Now, with the denominators, we do the same thing. 8 times this plus 13 times this. 8 times this plus the square root of 13 times this. We can then do some multiplication. We multiply 6 by 8 and 6 by negative 13. And of course, distributive law, we have the distributive law works over subtraction as well. So 6 times 8 minus the square root of 13 is 6 times 8 minus 6 times the square root of 13. But we've got to be careful with signs. I had a negative 6 here, It could get a little confusing, so you want to write it out real clear. Okay, then we do the square root of 10 times 8 minus the square root of 13, except it's minus the square root of 10. Okay, so it's minus the square root of 10 times 8 and minus the square root of 10 times minus the square root of 13. Now, we did have the question. Okay, it'd be easy to write this as minus the square root of 10 and minus the square root of 13, in which case we'd lose track of the fact that we're multiplying. If you're just used to writing out a number times a number and a number times a number and get in the habit of doing that and write this, well, that's where you really got to be careful. That's why we put parentheses around this, so we understand it's multiplication, because without the parentheses, we change the operation. It's no longer multiplication, it was a subtraction. Okay. Well, I'm going to raise effort. That's a good question. It came up. Okay. So anyhow, you get this. And in the denominator, 8 times 8, well, there it is. 8 times negative square root of 13, right there it is. Although I write that as minus 8 times the square root of 13, because we think of distributing over the subtraction. Square root of 13 times 8, right there. And square root of 13 times negative 13, or minus the square root of 13 times the square root of 13. Now we multiply the 6 by the 8. And we get 48. This term comes down just as it is. We write this term in the order of 8 square root of 10, because since we are going to be cued by what things look like, we want this to look like this and like other terms, in the sense that the square root goes last and the coefficient of that square root goes first. It's just a convention. But it's a convention with good reason. It makes it easier to look at what we're doing. It makes it easier to see what's going on. Okay, and then minus times a minus is a plus. We're going to write this as the square root of 10 times the square root of 13 for reasons that'll become apparent in a minute. That's a smudge. I haven't crossed out that square root of 10 or anything. Okay, in the denominator, 8 times 8 is 64. And square root of 13 times square root of 13 is 13. We could write that as square root of 13 times 13, which would be the square root of 169, but the square root of 169 is 13. And the reason is because square root of, well, it's not digress too much into the reason. Square root of 13 times the square root of 13 is 13, because square root of 13 is a number you square to get 13. So we get 13. We'll understand all that, and we pretty much do, but you want to be really careful. Okay, now we note that we have a negative 8 square root of 13 and a plus 8 square root of 13, which gives us 0, because these are equal and opposite. Then let's note that 48 doesn't combine with anything else, because 48 doesn't have a square root of 13 or a square root of 10 or any of that stuff. So there we have it. The 6 square root of 13 has a square root of 13 on it. So does the square root of 10 times the square root of 13. And we would lose that if we multiplied the 10 by the 13. So we really don't want to do that, because this is always going to match up with something. It can also be matched up with the 8 square root of 10. So there are a couple of ways we could write this. They come out to the same thing. And you can kind of check that out by doing it. Okay, so we're going to write the 6 square root of 13 and the 10 square root of 13 next to each other, so we can see that we can factor out that square root of 13. So we can have a negative 6 square root of 13 and a 10 square root of 13. And then we'll put the negative 8 square root of 10 out here in the end. Then we factor out the square root of 13. We can verify that negative 6 plus 10 times the square root of 13 is negative 6 times the square root of 13 here. And 10 times the square root of 13, same here. So we can use a distributive law to verify that we factored correctly. Remember that factoring is mostly just application of the distributive law. Okay. And it's kind of a backwards application. You know, we check it by applying the distributive law to what we get. Okay, well, then it's just a matter of adding the -6 and the 10 to get 4, and everything else just comes down the way it is. 64 minus 13, of course, gives us 51, and there we have it. Okay, so let's see how everybody did on this. Okay. Again, I want to emphasize, don't skip any steps here. Make sure you understand every step, because if you do, you're going to understand a whole lot of the important stuff in this course. It's going to be important to you when you get to pre-calculus. What we're doing here, when we rationalize this denominator, is we're actually dividing this number by this number, right? Okay. So that's a division. Okay, now you're going to see more about rationalizing denominators that we haven't gone over. So we'll see how that goes. We'll talk about it a little bit next time. And then we'll talk a little bit more about radicals. Now we're going to move on into some stuff about graphs and some stuff that actually you do at the beginning of a pre-calculus course. So you see how this stuff fits together. Okay, very good.